Do about 10 examples, and we're going to do some limits. So some of you guys started last week with this. So what we're going to do is we're just going to do a few examples, but if you have any questions excuse me, in connection with these limits, just let me know. So we are looking at this first example that say the limit as x tends towards 3 of x squared, is it x squared minus 9 everything over x minus 3. Okay, so I'm gonna try, and yeah, hopefully I think I will have enough space, so I will go on from this point onwards. So the important thing is, when it comes to these sessions, is that you take out a pen, and if you want to, you can take out a calculator as well for these things, because some of these questions you might need to use a calculator, and you might not need a calculator. Okay, so the other thing about these limit questions is simplification. So you in grade 12, I assume, or in grade 11, but this is part of the CAP system, so that's why I'm doing this. And simplification is important, so your algebraic skills is important. So that will be adding, subtracting, multiplying, dividing fractions. You will see that it's actually necessary, especially when you get to the section where you derive using your first principles. So that's why it's so important. So for instance, in this case, so the limit of this as x tends to 3. So x is not equal to 3. But if we substitute in 3 here, you will see that the denominator is going to be a 0. So the first thing, obviously, when it comes to determining your limits, is see if you can simplify this. And we can simplify this, okay, by factorizing this. This is the difference between two squares. So also important, don't ignore writing this. As soon as you do that, it will be wrong. So what you're going to do is you rewrite this. So it's going to be the limit as x tends towards 3. And like I said, this here is going to be the difference between two squares. So it's going to be x minus 3 and x plus 3. Everything over x minus 3. So now you can see, okay, this and this cancels. So now you can say, okay, if I substitute 3 in here, I will get 6. And this here is your final answer. Let's look at the next one. So the question number 2. Question number 2 is the limit as x tends also towards 3 of x plus 3 everything over x squared plus 3x. If you have the answer, you're more than also welcome to double tap the screen, or you can give me just a thumbs up. I can't actually read the comments. So let's look at this one. Can we just substitute in the 3 here? So let's just quickly see. Here on top we're going to get, so I'm going to do it in red. But it's best to simplify where possible. Okay, so let me just see what I'm going to get. I'm going to get here on top 6, and here I'm going to get 9 plus 9, which is 9. 3 squared is 9. Plus 9 is going to be 18. So it seems to me this we can simplify. So this answer here will be 3 can goes into that, 6 can goes into that once, and 6 can goes into that 3 times. So it's 1 over 3. But let's quickly see if we're going to get the same answer if we simplify it a little bit and then substitute the 3. Okay, so we're going to get the limit as x tends towards, this is going to remain the same, so it's x plus 3. And at the bottom, I can factorize that, so it's going to be x plus 3. Now you can see this and this cancel. Excuse me, I forgot to write the 3 there. So now I'm actually going to get 1 over x. So your final answer is going to be 1 over 3. Okay, so hopefully most of you guys got that answer. Okay, let me erase this, and then you can work on the next one. The limit, I know it's the limit as x goes towards 2 3x squared minus 4x, 3x squared minus 4x, everything over 3 minus x, so it's 3 minus x. Okay, first step is now to check if what's going to happen if we're just going to substitute in the answer. Okay, so let's do that on the side. Let's do that on the side here. If we substitute in 2, we're going to get 3 open bracket 2 squared minus 4 2 3 minus 2. So we're going to get 3 times 4, which is 12, minus 8 over 1. So here we're going to get 4 as the answer. So it seems to me we can just substitute in 2 because we're not going to get 0 here. So as soon as we get 0 here, we have to look at something else, because here on top you can factorize, but it's not going to cancel with the bottom one. So this is going to be useless to factorize the top. So you're just going to substitute in 2 and your final answer will be 4. Okay, so hopefully you got 4 as the answer. Let's move on to the next one, B. It is the limit as y go towards or tends to 1, y plus 1 over y minus 1. Okay, you only remember the question in the beginning. For those who have just joined us, make sure that you double tap and also share the live. In this way, more grade 12 students will see that we're busy with limits. The question is determine the limits if it exists. Let's have a look at this one. As you can see, if you substitute 1 on top, you're going to get 2. So let me just write it down. So if you substitute 1 on top, you're going to get 2, and here at the bottom you're going to get 0. So undefined, but also the limit don't exist. Okay, in some schools question papers don't you allow to do this. We can just draw a line through that just to tell you that the limit don't exist. If you're not aware of this here, you can, this is between us, okay? If you don't use it at school, please don't do it, okay? So the limit don't exist of this one. So let's move on to the next one, which is going to be C. So this limit is tending towards 4, and it's x squared minus x minus 12, everything over x minus 4. So first of all, let's see what's going to happen if we substitute 4 in here. I'm going to do it here on the side. Here on top, I'm going to get 16 minus 4 minus 12. And here at the bottom, I'm going to get 0. So it's going to be undefined. So I'm not going to even bother simplify the top. But here, I can see that I can actually factorize the top, and maybe it will cancel with the bottom one. Okay, I'm not sure. So let's see. So it's the limit as x tends towards 4, and this here I'm going to factorize that. The bottom is going to remain the same, so it's just going to be x minus 4. I'm leaving as it is. Here at the top it's going to be 2 brackets. It's a quadratic equation, so that means 2 brackets x, and then minus 4 and plus 3. So as you can see, it's very important that you know how to use all the algebra that you've learned up until today, okay? Everything. So here we're going to get the limit. As you can see, I'm not leaving this notation. I'm not just writing this part because I'm simplifying. I'm writing down everything because I didn't determine the limit yet. So I'm just simplifying this fraction here. So as you can see, this and this can this is supposed to be 4 here. This and this cancel, so all that I'm left with is x plus 3. And now, as you can see, if I substitute 4 in there, I'm going to get 7, and this here is your final answer. This was P, but anyway. Okay, so it's C. The limit as x tends towards 2 of everything inside brackets, which is 3x plus 1 over 3x. Okay, first thing, First of all, if you want to, you can simplify this, but I think it's going to be useless. Also, this is from a question, not a question paper. This is from a textbook, so they don't give you the mark allocation. But let's see what's going to happen if we substitute in. By the way, we're not going to get 0 here, so it's going to be okay if we're just going to substitute 2 in there. So it's going to be 3, 2 plus 1 over, what is 3, 2. So it's going to be 6 plus 1 over 6. So this is going to be your final answer, okay? You can simplify this if you want to, write it as a improper fraction. But I'm going to leave it there because they don't give us, there's no mark allocation. But the important thing is here just to say that a limit don't exist, and if you can substitute that number. In this case, yes, I didn't get 0, so I substituted in there, and also there was nothing to factorize and cancel out to make it much more easier so that I can substitute this at the end of the day. Okay, that was C. If you got that answer, please let me know. Okay, so let's move on to the next one, which is quite an easy one. Maybe I can just, me not be lazy. Okay. So we're looking at D, and this one is just the limit as x tends to 0 of 1 over x. Okay, you need to ask yourself, does the limit exist? Quite an easy one because I've already 0, and if I substitute in here 0, I will get undefined. Okay, so that means the limit don't exist. Okay, and that will be your final answer. So let's move on to, that was D. That was D. Let's look at E. So for those who have just joined us, make sure that you double tap the screen. It is way more grade 12 students can see this. I can't promise that this will be on my YouTube channel because sometimes TikTok upload it onto our platforms, and then we can download it, and then we can upload it onto our YouTube platform. Now there's nothing to simplify here in terms of factorizing and cancelling, so only thing that you can do now is substitute in 1. So here on top we're gonna get, did I write down the correct one? Yes. Here I'm gonna substitute 1. I will get 1 minus 1, which is 0, and on top, let me just write it, and 1 plus 1, which is 2, so that means the limit is 0, and this will be your final answer. So the limit does exist, it's actually just 0. Let's look at G. So we get the limit as h tends to 0 of 3h plus h squared, everything over h. Okay, so let's look at this one. As you can see, if we substitute 0 in here, on top we're going to get 0, and the bottom we're also going to get 0, and it's undefined. But we can see, okay, we can actually factorize this. Okay, so first of all, let's write that down. So it's going to be the limit as h tends towards 0. Here on top, I'm going to take out my h as a common factor, and then left with 3 plus h. At the bottom I have h as well, so now I can see, okay, I can actually cancel this and this, and that's the power of your knowledge that your algebra knowledge and stuff that you've learned up until today, okay, in terms of algebra. So now I can see this and this cancels, and if I substitute 0 in here, my final answer will be 3. So the last one is h, and we have here the limit as h tends towards 1 of h cubed minus 1 over h minus 1. So as you can see, if we substitute 1 in here, let me just do this, we're going to get 0 on top and 0 at the bottom, which means undefined. So that means, let's see if we can, before we say the limit don't exist, let's first see if we can factorize this, and yes, we can. So this is grade 10 factorization that you've learned, factorization that you've learned in grade 10, which is the difference between two cubes. Okay, so we still write that down. So it's the limit as h tends towards 1, and here on top I'm gonna have a small bracket, as you know, and a big one. Okay, and at the bottom obviously this is going to remain the same, so it's h minus 1. And what is the rule of differentiation? Excuse me, not differentiation. The rule of the difference between, it's here supposed to be a positive, negative, the negative that's there, and then it's plus and plus. And then further on, it just say the cube root of that, which is h, cube root of that is that. And this is going to be here, but square it. You need to square it, okay? And this multiplied by this is going to be here, which is h. And this squared is going to be 1. So now I can see, okay, this and this cancel. So the only thing that I'm left with is now obviously this mess here, which is h squared plus h plus 1. And if I substitute 1 in here, I get 1 plus 1 plus 1, which is equal to 3. And this is your final answer.